Okay, Euler's method, example 2. So it says use Euler's method with step size 0.1 to estimate, and we're going to make it 0.3. You do the same thing over and over again just to make life easier so you don't have to go through as many iterations. Where y of x is the solution of the initial value problem, blah, starting at 0, 1. So I'm starting with 0, 1, okay? So, and I'm counting by 0.1. So I'm going to do 0.1, and these, I probably need more space here. 0.2, 0.3. This will be my answer right here. Okay, and I know that my change in y equals my change in x times dy dx. Okay, so I'm going to write, I'll tell you what I'm going to do. I'm going to move this whole thing down. No, I'm not. I'm going to group this, curses again. I'm going to group this whole thing, and I'm going to, yeah, I know y'all are laughing at me right now. Yes. Okay, I'm going to move this down, and I changed that to 0.3. I'm going to actually say the change in y equals the change in x times y plus xy. So you can see where we're getting these from. So for this one, my change in y is going to be my change in x, which is going to be 0.1 every single time, times y plus xy. Now these are coming from here. 1 plus 0 times 1. Okay? So what that's going to get me is, let's see, 0.1. This equals 0.1. So I'm going to add 0.1. Alright? 1 plus 0.1 is 1.1. So now I'm going to do it again. My change in y equals 0.1. This value does not change. Okay? This x and this y come from this point. So it's going to be 0.1. Nope, just kidding. That's a y. 1.1 plus 1 times 1.1. See, y plus x times y. That's a point right there. Okay. I know y'all tell me tomorrow if I mess up, so I'm double checking myself. 0.1 is 1 plus 1 plus 1. Okay, this is correct. When you stick that in your calculator, you get 0.121. So that's what I'm going to add. So I add 1.1 plus 0.121, and you get 1.221. Okay, so I'm going to do it again. The change in y equals the change in x. This value stays the same every single time. My y value is 1.221 plus my x, 0.2, times my y, 1.221. Okay, double check myself. Yes, 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 we're good. Okay, you stick that in your calculator, and you get 0.14652. Go ahead and give you these values up here too. This was 0.121, and this is 0.14652. You add these two together, and you get 1.36752, and that's my answer. I just used Euler's method with step size 0.1 to estimate y of 0.3, where y of x is the solution of the initial value problem. Done. Let's do another one.